The basics of this topic, functions, are a review from last year, but I'm also going to lay some groundwork that you'll be referring to throughout your study of mathematics in high school and beyond. So in general, when you think of functions, you probably think of our function machine. But you may remember from last year that a function is the correspondence, and that means a relationship, of two groups, and in math we call these groups sets. One of the groups is the independent. And remember, we used to say a function is a function, something is a function if something depends on another. Independent. Okay, I'm going to run out of room here. Let's just go down. Of two groups or sets, the independent which in algebra and beyond is going to be called the domain and refers to the X, and the dependent. And the range for that is, the word for that is range, and it refers to the y's of a function. Just this past week when we did the amusement park problem, we were talking about the number of rides and how much it cost. And if we thought of that as a function, what we would say is that the cost depends on the number of rides. Therefore, in that group, the sets would be, the domain and range would be, the number of rides would be the domain, and the cost would be the range, because how much it cost depended on the number of rides. So, and highlighting on that, going further, basically functions are stuff that can be graphed, because we have the x-axis, and as we've seen before, that this is where we graph the independent variable, which from now on we will be calling the domain. And that's the set is called the domain. And here we have the y, and it is the dependent, otherwise known as the range. And just like we did in the amusement park, we graph these on the two axes. Now, one of the things that when we're graphing for homework tonight, I want to make sure that you have a uniform interval for each of these. This is the part that's review as well, but this can be a tricky thing. So you need a uniform interval. In other words, if I have my number going up from 0 to 2, then the next one has to be 4 and 6. So you have to look at your data and figure out what interval makes sense and then graph it from there. You are going to be doing some bar graphs, which I really hope at this point you can do. But then there's also going to be some broken line graphs. To do a broken line graph, you would plot your points and then connect the dots. And there will be a graph like this. So let's say your points are here, 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 and here. Then your broken line graph would look like this. Okay? So first thing when you're making a graph, you need to sketch it out and figure out, look at the data and figure out your interval. And then when you're doing a broken broken line graph, you want to plot your points and then connect them. There's one other thing that comes up later in future topics of algebra and beyond that is a distinguishing characteristic of functions. And the way I illustrated it today in class was to look at a chart of birthdays. So this is the chart of the function of famous people's birthday. George Washington's birthday is February 22nd. We had Marie Curie, the famous scientist, who's November 7th. Then we had, and this is an interesting true fact, Charles Darwin and Abraham Lincoln, two of the most influential people of the last 200 or so years, and they ended up having the same birthday. And that is, it just happened, it's February 12th. Using this idea, this is a good illustration of an idea about functions, where if we think of this as the domain and this is the range, each x has only one y. In other words, each x, each person, has only one birthday. But more than one person more than one x, in the general sense, person, can have the same y. And that's birthday. And if we think about what this means in a graph, what that means is that in order for each x to have only one y, it means that you cannot draw a vertical line through 2 points in the graph of a function. It's actually called the vertical line test. So let's just call George Washington the first person, Marie Curie the second, Charles Darwin the third, and this the fourth. And let's call this the first birthday, the second birthday, the third birthday, and now it's the same. Okay? So if we plot these points thinking of a general coordinate graph, George Washington would be 1, 1. Marie Curie would be 2, 2. Charles Darwin would be 3, 3. And then Abraham Lincoln would be 4, but also 3. So they make a horizontal line. If we were to say that the same person, the one person could have two different birthdays, let's say George Washington could have this birthday and then this one, it would make a vertical line. So that's how you know when you don't have a function. So for example, if I draw a parabola, there are no points here that in this function that lie on the same vertical line. But if I drew the sideways version of that, these do. These are 2 points in the same graph that are vertical from each other, so that would not qualify as a function. That's just something to be thinking about for the future, just a seed to plant. But that's really all this is. We're going to move on to function notation and more sophisticated analytical and algebraic uses of this. But for tonight, that's it.